Hey everyone. So about a year ago, when LWRP in Unity Engine was first released, I was really excited, and I think really one of the reasons why I kind of really jumped towards it was because I'm working on a game where lighting is kind of a very major component to it. Having darkness is very important. And prior to that, Unity didn't really have any in-house solution for uh, good lighting. Of course, there's probably Unity assets that kind of add lighting, but to be honest with you, this one looked so good that it was like any other asset that someone else created probably wouldn't be as good. So I don't know if there's any assets that exist for dynamic lighting and things like this in 2D. But regardless of that, Unity made their own, and it's really awesome. And so at the time, I was like, oh yeah, cool, lighting, lighting, lighting. But then I saw this video somewhere on the internet where this guy used the universal render pipeline. That's what it's called now, but back then it was called LWRP. But at the time they had, I think it was like a demo project or something. I'm not sure, but it was like this game, and it was a video, and that I saw on Twitter, I think, or well, no, it was a YouTube video, but I saw it on Twitter as well. And it was some game where the background, you could see there was lighting, and so it was lighting up the platforms. It was a platformer game, and there was a wall, and that would get lit up as well. But the thing is that the wall actually had like these kind of glowing emissive pieces that would move around, kind of like what you see here, where this kind of magma floor has like these glowing pieces that move around. So it was kind of like that. And immediately I'm thinking to myself, I want to add this in my own game. And I'm trying to think, okay, so, let me try to add it. Of course, obviously, making this effect look good also requires post-processing. So if you don't have post-processing, that's going to be an issue. But I tried doing this from the get-go, and it didn't really work. And I can show why it didn't work for those of you who might be confused. And for those of you who have went down the same path that I went, where it's like, I want this, I want lighting and nice lighting, but then I also want to be able to make glowy effects, so that in dark areas you can see, hey, it's glowing and stuff like that. And I'll explain to you kind of my solution that I have now. I've had other solutions in the past that worked, but they were kind of clunky and made me not want to use them anyway unless I absolutely wanted to make something, but it was clunky, But I recently discovered a new solution, which is still only a temporary solution because the 2D renderer in URP is still, experimental, as they say. When you in various places you'll see the word experimental because they're emphasizing the fact that a lot of stuff could change, so this solution could break in the future. But I want to show you how I actually did it in as little time as possible here without rambling too much. So essentially, my current solution, which I discovered the other day, is that if I click on my shader graph, you can see I've made my own master node, because the issue is that the normal Spritelet Master node, and yes, you can have multiple master nodes, you just have to click set active, but what happens with the normal Spritelet Master is that you plug in your data, and the idea is that the shader code that gets generated automatically applies your lighting data, the lighting data of this part of the area is black, here it's bright because there's a light there. And so essentially, if you applied your emission data here in your shader and then plug that in here, the lighting data would basically, the emission stuff would get blocked out. And so really what you needed to do is have some way to have that lighting data be applied after that emission data. There's emission data and lighting data. You want to wait for the emission data to be applied after the lighting data is applied, so that the shadows don't affect that. Of course, if you want it to be affected by it, then that's totally fine. And so for a long time, I had my own solution that I had discovered, and I can show you, but that'll be kind of pointless. Although maybe in a different video I'll show it, but I want to keep this one short so I'm not boring you people. But if it does get long, I will maybe put a timestamp down in the description. So check the description. If this video is long, check the description. I'll say that right now, right off the bat. And I'll elaborate on what I'm talking about here. I'm going to go over to this other tester project that I made. And you can see I'm using In this shader, I'm using Spritelet Master. And what I'm doing is I'm taking my sprite texture, that's the main text, and I'm sampling it. And then what I'm doing is I have this triangle here that I'm using as my lighting data. So in this case, the light is completely white, or not lighting, emission, I'm sorry. So this is my emission data. So it's a triangle. I'm making it a little darker, and then I take that emission data and I add it to the texture data. Okay. Now this is still, you know, when we get to this part of the graph, lighting data hasn't been applied yet because it's applied inside this node. So I have no way of controlling that. Although if we did have a way to control the lighting data from here, that would be quite nice. But they didn't give us that ability. And if you're thinking that's what the mask node is for, no. The mask node is actually just for masking the light so that it doesn't show at all. So even if you put emission data here, it's going to block that as well. And in case you're curious, in case you're like, well, I tried using this, but it did nothing, I will say this right now because this wasn't very apparent to me until someone on Twitter showed me or explained this to me, that for the mask to work, you have to go to your 2D renderer data, you go to mask texture channel, and you select one of these channels, or you could select one of these, but it'll do the inverse. And so you'd click R, and then what that means is that the R channel is basically going to be what you use for your mask. So, I mean, your mask is still going to be, you know, a black and white grayscale, but all the color values are going to be the same. So the idea is you could use the red for this blend style and then green for this blend style, so on and so forth. But that doesn't mean that everything is going to get masked and shaded as that color. It just means that that color channel is being used, that grayscale channel is being used for the color itself. So if you're wondering, you know, why doesn't the mask channel do anything? It's because of the fact that they're doing this here. Okay, just so you know. Although I believe you could actually make your own mask. I think you could do your own masking, you know, in here, I think. So yeah, but anyway, let me move on. Move this over here. So as you can see here, traditionally this is what you might expect if you're in the situation where I was in, where I'm like, okay, you know, I'm watching all these videos and they're telling you that if you want to add a glowy effect with the post-processing on, then you basically take your emission data and you add it directly to your texture, and then you plug it into the only node that has anything to do with color. I mean, the mask is a color, but it doesn't, that just masks colors. It doesn't add color in any way. So if we hit save and then we go to my game view, you'll see I have some lights set up here. So blue, green, and red light. And you can see that the parts, these triangles, those are the parts that should be emitting light. All right. And if you think about it, you know, like the sun, think about the sun, right? The sun is in the middle of space, and the space is black. It's pretty dark. But that darkness doesn't make the sun invisible. It's still in broad daylight. You know, we can see it. And the reason why is because it's emitting its own light. So why is it that that triangle there that is supposed to be emitting its own light from the surface of bricks, which is kind of weird, why does it become dark? Why is it dark? Why is it affected by the lighting? That doesn't make any sense. And so this annoyed me very much because that's not supposed to happen. And I thought that there was no way I could do this because there was no way I could make my own master node to kind of bypass this fact of the node basically shutting out all my hopes and dreams of making a really awesome shader. Oops, sorry about this. So I need to come up with a solution. And I did have a very hacky solution that included basically, in short, making like this. Well, there's basically these textures which hold the light data that is applied in the master node. And the idea is you use an unlit master node. You apply the lighting data in here, and then you plug it into here. And that works, but there are some issues here and there and whatever. And also, every time you make a shader, you have to do that every single time. And it's like, well, I don't want to do that. I just want it to work and not me have to add that texture in every single time. So recently I got fed up with it, and I'm like, I want to make, you know, this is going to make our game look great. You know, I mean, don't get, you know, seriously. Like, this looks awesome. This, oh, okay. this looks really awesome, having these like red glowy bits moving around, and this wouldn't be possible if it wasn't for what I'm about to show you. But it required me to do a little bit of modding to the universal render pipeline. So I did have to copy and paste some code that was in both the shader graph package and the universal render pipeline package. Not a lot, but I had to copy and paste some of those files, some of those scripts and shader scripts, and basically modify them so that I could have my own custom master node, which I call Spritelet Emit. And I can show you actually this here. So essentially, all I have to do to make this work, and I have it down here, I have it hidden, but here's the Spritelet Emit master node, and you can see here I just added in a emission node, just like that. So now what I can do is I can set this to active, I can delete this node, and then all I have to do very sensibly is the color is just the color. So you plug that into here. Color goes to color, texture color goes here, and then the emission data goes in there. So if I just hit save right now, so right now the emission is black, so no emission, you get what you expect. And if you go to the scene view, you click this, voila, right? I don't know if the mask works though. I might have broken some stuff, but it works for the most part. I don't really use the mask plug anyway, so it doesn't matter. So as you can see here, now what I'm going to do is I'm going to delete this, and I'm going to take the lighting data and I'm going to plug it into the emission. And so essentially what's happening internally, and I can show you actually what's happening soon, but essentially you have this node, this is the color, this is the emission, and then in the shader code that comes from this, it basically takes the color, applies the lighting data to it, and then after the lighting data is applied, it then adds, literally mathematically adds this emission color data to the already processed color with the light. So now if we hit save, that probably didn't make any sense the way I worded that, but you can see we have some nice bright white triangles here. And some of them have like a little bit of a green halo. And if you're thinking, well, what if we want the triangles to be based off of the color of the thing they're being emitted from? That's a good question. Not really super relevant here, but it's a cool thing to note that you can do this. You know, this is the big thing that makes this awesome, I think, is that, and if you've seen our Twitter, I did post like a video kind of showing off this whole thing actually, but I didn't show how I was doing it, but you could see I was showing all these different sprites that were glowing, and they were glowing in the color of the sprite itself. So it wasn't me going, okay, I have to pick the color. No, it automatically happened, which is cool. So essentially you take the texture, you take the lighting data, and you multiply them together like this. And so you get lighting data that looks like this, and if we make this, say, 1, instead of multiplying it by 0.5, multiply it by 1 so that it's a little bit brighter. And then we plug this in to here, so now our emission data is no longer just white, it is now brown. It is the color of the sprite itself. So if we hit save and we go back, you'll see that voila, the brick, which normally brick doesn't do this, but the brick is emitting light, and it's very, very, very sharp light. It has infinite detail because it's a triangle, so it doesn't rasterize at all. But you can see here we have a surface that is capable of emitting light, but also reflecting light. You know, those are the only two types of light that exist. You have indirect light and direct light, right? So essentially, you know, that's really the effect that I was trying to get from the get-go, but this required some really hacky work. And so now I'm going to show exactly how I did this. Now I might end up actually putting a link in the description for you guys to download the code that that is used to make this work. But the only thing I will say is I might not do it. I'm not going to do it unless a lot of people, for one thing, if a lot of people ask for it, then I might. But also I have to consider that this code originally came from the URP package, so it's someone else's code, and I'm afraid to just publicly release it because I don't want to get in trouble with anyone for doing that. But again, this is like, you know, all I'm doing is modding. I'm not, you know, I'm giving this code out. I'm not selling it. It's just, I'm just saying here, you know, so it's kind of like, you know, I guess, not that this is relevant, but I'm thinking like another example is like Minecraft, where people decompile Minecraft's code so that they can add modifications to it and then release them to the public for free. So in a similar way, that's what I'm doing. I've basically just modded the universal render pipeline to add in a new node. And if you're wondering why there's an S here, for whatever reason, that was a typo. I just typed it really fast. So yeah. So you're probably wondering now how I did this, and I'm going to show you. Also, I made it a little bit brighter so you can see there's a little bit of bloom there. You can see. Anyway, let's move on. So this is how I did this. Again, if you go in the description and you see a download link, then you can just download that, and I'll show you kind of all the ins and outs of it. But I will show you exactly how I did this. And I have a feeling. I was just thinking before. I have a feeling that in the newer versions of URP, this has probably been fixed, or there's already a solution. Because right now I'm in a slightly older version of Unity, so I'm using URP 7.4.3. But I believe there are even newer versions of URP that exist for newer versions of Unity, but I don't know what they've changed or what they've done, and I don't know. But at least for this version, this works. So hopefully, even in the newer versions, this is relevant to any of you who wanted to create really cool effects like this, or, you know, if you've ever seen, you probably knew what I was talking about when I talked about that game where the walls were glowing blue and there had these little squiggles that were, you know, moving in this glowy pattern. It was really cool looking, and I was like, I want to make that. So everything I've done here is because of that, really. So anyway, if I move over to my project directory, I have this folder which I called Lit Emit Shader Extension. You know, and if you put this in another folder, then this will not work, and I can show you why. But essentially, for one thing, there is a script in this folder. It is it's a HLSL. It's high level shader language code in here. And if I open this up, this is code that has been copied and pasted from the URP, except the only changes I've made is I've added in the part where, as you can see here, I'm adding the emission data to the actual lit color. So obviously, if the lighting data at a specific point is black, then this color will be black. And so then we're adding our emission data to it, and we have our nice glowy goodness. And then also here, I'm doing this little. I mean, this code is not very good, but you know, I'm making the final color alpha equal to the lit color alpha, so that, you know, transparency works properly, because the transparency of the lit color is going to be totally fine, not a big deal. So anyway, that's really all I changed here, pretty much. The only, you know, all that was before was that this line of code right here was here originally, and then I put it here in a variable and did some other modifications to it before then returning it. But that's the frag function. You can see I didn't do anything here, of course, just here. But all of this is, you know, the original code that's just been copied to a different place, and I'm returning it. And you're thinking, well, if this is a frag function, so this is, you know, if you've worked with shader code before like this, you'll know that the frag function is basically the main function for your pixel shader, you know. And you're thinking, well, you know, I don't see all the stuff that you need here to have a function. You're like, where's the rest of this stuff? Well, the rest of it is actually in, well, I'll show you. So if we go and we click and we click and we click and we click on the Spritelet Master and we click Show Generated Code. So this is the code that's generated once you click Save Asset, which I probably shouldn't have did that. Here we go. That worked. So as you can see here, it's a custom shader. No, I don't want to update. Spritelet Emit Master. So you can see I added the emit part. That's my part. Everything else was original. Spritelet Emit. Keep scrolling down, and you'll see really the one major thing that's different in this automatically generated script is that if we scroll down, now this, of course, as you can see here, this has my multiplies. So that's what these are, although I'm kind of confused as to why exactly why exactly there's two of them. They're the same thing. I don't know why. Oh, because the one is for single and the one is for or float for, which makes sense. Okay. We have our surface description, which is basically the outputs. It's not all of the outputs. It's only the, in this case, it's the colors. So you can see color for emission and mask. And here you can see color, emission, and mask. So those are those. And then, of course, you have surface description inputs, which I believe are the vertex. That's the vertex data for the vertex shader stuff. So anyway, that's this emission data. I had to basically, that is different from what would originally be there. Originally, it would just be color and mask. So this code is generated by a C# script somewhere. And basically, I had to also add custom C# scripts that were based off of original ones that said, okay, also, by the way, add in this as well. And you can see here I have this, there's this function called surface description function, and this is actually where all of your shader code exists. That's all of this stuff right here. That's this right here. And then you can see surface description is what's returned, and as you can see, that is this right here. I don't know why it's called surface description. They could have called it maybe something else. It's a little more sensible, but I kind of get why they called it that. Also, I think this is actually something different. This is not what I think it is. This is not the vertex. There's a thing called varyings. I'm not going to go looking for it, but well, here it is, the varyings. This is for the vertex, I believe, or this, one or the other. But you can see here we're returning this type called surface description, which has all of our data. So essentially, you can kind of think of it as this is our nodes, and then we're returning all of the data which we are plugging into here. So we're returning it and we're giving it to something. But what are we giving it to? Well, if you scroll down, you'll see eventually that there is another change, which is this right here, where it says assets lit emit shader extension sprite lit emit pass. So this is what I meant when I said if you put the folder in a different location, or if you try to mimic, if you try to, you follow the directions that I'm showing you to do this for yourself, obviously you need to make sure that wherever this thing's being put, that the directory doesn't change, because obviously this will throw an error because it's not going to find it, because it's based off of where this is. And so if you put the folder in a different, like if you say assets / shader mods / lit emit shader extension, it's not going to find it because the directory isn't the same. So if you do change it, make sure that this gets changed, but don't change it here because this is auto-generated. I'll show you where this comes from. But essentially this include preprocessor directive. Is that what it's called? I forget, honestly. The preprocessor directive, I believe it's called. But basically what this does is it takes the code at this directory, at this text file, takes it, copies it, and pastes it literally automatically when this runs and it's compiled. It pastes it right here. Okay, so that is, in fact, this right here. So this just gets copied and pasted. You can see here, actually, here's the surface description function. This is the function which, when you call this, it basically runs your entire shader graph. That's what this is, where you have all these nodes connecting to each other. That gets turned into code, and then that's what this is. They should have just called it the graph function, compute graph function, or whatever they want to call it, but they chose to call it this. And so essentially, you call this function, you plug in your surface description inputs, whatever, doesn't matter, but then it returns this thing called surface description, which then is used in various places, but the important place that it's used is here, surface description color, surface description mask, and then, the coordinates and all that stuff. And so what this function does is this function is actually what computes the lighting data. So if there's a spot in the area in the game where it's dark, then that part of the light data texture is going to be black, and so it basically just takes that and multiplies it with the texture color at that location to get black. But if there's a light that is blue, well, then you take that blue and you multiply it by the texture color beneath it, and that resulting color, whatever it might be, is going to be the color at that location because there's a blue light there. But the problem is I need to be able to add the lighting data after or I need to be able to apply the emission data after the lighting data is applied. And so that's what this is doing. Okay, we're just taking our lighting data, what's already happening, and we are adding the emission data, and that's where the surface description comes in. So, of course, I can, make the emission data be whatever I want through the graph here, but, here, this is the part that doesn't change. It takes all of that information I just computed and kind of finalizes it into this final color. That's what I named this variable in particular, and this one as well, because this was just here. It was in the return. So the final color is then just fed into this, and then it's then rendered, because of course if you're just, if you're not using shader graph and you're just doing normal shader coding, then this is basically the end of the line. Anything that happens after this is done internally by the GPU, and then eventually, your pixel will be rendered on the screen. It'll be set and all that good stuff. So with all of that being said, that's not it. That's not it. So that's what this is. Okay, so this is just the HLSL that's used internally by this custom master node to render everything. So again, this is code that this is Unity's code. Okay, this is all Unity's code, Unity developers. But I've basically modded in this piece right here. And then there's two other scripts I needed to actually make this node work, because you're probably thinking, well, this is an editor thing, so you need to tell the editor that this thing exists, because all I have to do is say create node master, and there you go. See, and I also added my name as well in there, just so I know that obviously this is something I've modded in, it's custom, and obviously in future updates this could definitely break. And if it breaks, then maybe that means that they've finally added in a solution for what I want. And if they never do, well then I'll still have this, or I'll have a different version of this, or something like that. Because one way or another, I want my glowing lava, or my glowing whatever, okay? So, yeah. So if we go here and we click editor, you can see I have 3 things. I was hoping just to have 2 things, but I was getting compiler errors here saying, oh, this doesn't exist. And the reason why is because there were some classes in the package, in the URP package, in the shader graph package, that are not public. There's some classes that are just not public, so I can't inherit from them, and because I can't inherit from them, none of this would work. And I discovered that if I right-click, and I don't know how I discovered this, I just took a wild guess, honestly, and I went to right-click, create, assembly definition reference, and then I basically just said, okay, I hope this works. Clicked on here and clicked unity.renderpipelines.universal.editor, clicked on that, hit apply, and then all the errors went away, and I was like, oh, cool. And I also had to fix some other errors as well. But basically, these 2 scripts are copies of scripts that exist inside of the package, inside of the URP package, but I've modified them so that I can have my own master node. I'm emphasizing this, that this is all for modding, and if I ever do release this, I'm not, I'm just giving it away for free. It's, and it's stuff that I'm explaining this, so even if the download link isn't in the description, you can hopefully kind of follow my instructions to do exactly what I've done so that you can mod URP for yourself and get this nice lighting. But as you can see here, if I click on this first script, you can see I have Spritelet Master node. So originally it was just called Spritelet Master node. And so that was the script that basically put the Spritelet there, that thing. That's what made that exist. But basically I copied it and added the word emit to the class name. And I have this error here, but it still works. I have this error squiggle, but it still works for some reason, which is fine. I don't care. Probably down the line when this function gets called at some point, if it ever does, for creating common settings elements, I might get an error, but I never have yet, and that's fine. I don't care. So essentially, I copied and pasted the code for the most part, and then renamed some things, commented some things out because it doesn't make sense. And then obviously, it's a master node, and it's called Spritelet emit. So it's a lit, but it also has an emission component. And I added this little thing in to remind myself and any others, if this does get downloaded, that it's custom and I made it. It doesn't matter who made it, but, It's custom. And then of course I added in some stuff here. Oh, I had to add in the special slot itself for the emission node. So you can see it's a special slot. So you can see here I had to add in, I had to add in a special thing here for the emission slot. Also, I added in the emission color slot ID, and I made it 3, although this number could be different. But in this case, that's what it is. And then down here, I had to add in a emit color slot ID. I had to add this whole add the slot in so it existed. And then also down here for the emit color slot ID and all that good stuff. This I didn't have to change because it's all, well, I didn't exactly know what it was doing, but there was nothing related to color down here. It's just tangents, positions, and normals and all that stuff. So it's whatever, small script, but basically this is what kind of sets up, I guess, the master node to exist and gives it all of its data. This could have all easily have been in a JSON, but they decided to do it this way, and that's totally fine. Honestly, they're probably better off doing it this way anyway, because it's, well, serializable. They're using this serializable the Unity serialization system, the Unity. Anyway, and so the reason why I was getting, I keep doing this to myself. The reason why I was getting, like, the reason why I had to use this assembly reference there is because this material master node, I would get this error saying it doesn't exist, because obviously even though I'm using the same namespace, it's in the same namespace, it would say it doesn't exist because it's not in the same assembly. And so I had to say, hey, look at this assembly. Use this assembly, damn it. You know, please use it so this can work. So I got it to work. And so that's that script. That's just making it so that the assembly node shows up and telling it that it needs to have this specific slot for data. But now you're probably thinking, well, that data now needs to be sent to a shader that is generated by the node itself. And so that's where the universal Spritelet, what is it called? Universal Spritelet Emit Subshader. So it's the subshader. I honestly don't exactly know why it's called a subshader. I know that's a topic of shaders. You can have subshaders and things like that, but I'm kind of confused. Well, actually, no, I'm not confused why it's called a subshader. It's just, that's just what it's called. But this essentially generates the shader information. And so you can see here, I'll show you the changes, but it's just a universal Spritelet Emit Subshader, and then there's this interface I made, which is actually blank. It's empty. I mean, that's how the original one was. But here it's just iSpritelet Emit Subshader. Here you just remove emit, Spritelet Emit Subshader. That's the interface that originally existed. And you can see here the changes I've made. Reference name, shader pass, Spritelet Emit. Here there's this thing called pass include, which is important. That's actually what you need to change if you change the directory. So if you put this in a different folder, you have to make sure that this directory reflects the place where your HLSL script exists. That's the thing I showed you originally back, well, here. That's this piece right here. So this is the, you have to make sure this directory is correct, or else you're going to get an issue. I also added, this was important, I had to add, this is the part. And so here you can see it says Spritelet Emit Master Node. So this is the master node, and this says Emit Color Slot ID. So this is where the slot ID comes into play for the pixel shader, for the vertex shader. And then I believe somewhere down here I made another change, or maybe not. Probably not. No, because this is the normal, and I didn't mess with the normal. No. And so essentially this script just basically tells the system how to generate the underlying HLSL code, which is, that's what this is. This is automatically generated shader code for the shader graph. And as you can see, it's one of the things that it adds is this include at the bottom, which actually has the air quote main function of the shader, which basically calls this function called surface description function, which has, this is the graph itself. So this gets called by that frag function that's included at the bottom, and it works. So if we scroll down, if there's something else I wanted to show. I mean, that's all the changes I pretty much made. I don't think I made any other changes. Everything else I just left. There's obviously going to probably be some minor issues and weirdness going on, but that's because it's code, modded code on top of a system that's still in experimental phase, so things can break, but I'm okay with that. I'm totally fine with that. Let's see here. Keep scrolling down. So you can see here, this is the interface. This was in a different file originally, but I'm like, you know what? I don't need to put this, I'm not going to make another file. So I just put it at the bottom, Spritelet Emit Subshader, and it just inherits from this thing called iSubshader, which actually does have some stuff. And then there was, down right below it, there's another thing, and it's actually two things, actually, and they're actually these static classes, which I haven't changed at all, except the only difference is that these actually existed somewhere in the URP package, but you can see here, they're just static classes. So it doesn't say public, it just says static. So it's not public, so I can't access it publicly unless there's another way I could do it, that I could do it, that would make it work, but I just don't know, and I wanted to get this to work. So basically all I did is I took the code in those scripts, since it was just a bunch of helper functions essentially, and I copied and pasted them, not knowing what they did, into this, jammed it all into this universal Spritelet Emit Subshader, so that I could just get things to work. So essentially I have, this weird static class in here that exists somewhere else, but here it doesn't know it exists, so I just put it there anyway, so it works. And then I took this other script because it was also giving me some errors as well, and I copied and pasted this as well. But you can see all of these things are unused except the things that it is using in particular, I think. I forget exactly what it was using, but it's just other class with a bunch of static functions, and, well, it actually has, well, hold on. So this actually has, structs that are being treated as subclasses or inner classes, or I think they're called nested classes, I forget. But essentially this was just in another file, and I copied and pasted it in here so that I could get rid of all those errors saying these didn't exist because they didn't put a public there, they left it as private. I mean, they probably did that because they didn't want people messing with this stuff, and then, they've post an update and then people's shit breaks and they're like, and everyone's like, why does my stuff break? It's because you basically, made your code depend on this stuff that is highly volatile, and the code is likely to change. So that's why they made it. It's not private. It's like, if you leave out an access modifier for something in C#, that doesn't mean it's private. It's private, but there's also some other nuances to it. I forget though. I think it's the same thing as internal, or, well, no, it's not. No, it's not. Anyway, doesn't matter. So essentially, I just copied and pasted this thing and this thing that were in some other files, and I put them in here at the bottom so that I didn't get any errors. And one thing I also noticed just a minute ago is, as I was scrolling down, one of the things that did change is that anywhere in the code where you use the class name Spritelet Master node, I basically added in emit. So as you can see, if I scroll through, and also that applies for other things as well, but you can see here that all of these places that are highlighted where it says Spritelet Emit, those were changed. And so obviously, I had a little error squiggle there, so I knew that those things need to be changed. So I just scroll through, pasted just to, get rid of the error squiggles, or whatever they're called. Compiler error squiggles, or whatever you want to call them. No one has ever called them that, but I'm going to call them that because that's what I like to call them. I don't know what else to call them. Also, these right here, of course, which I did show those before, so that's nothing new. But basically, I went through and made sure that all of these class names were changed so that they didn't say Spritelet Master node, they said Spritelet Emit. Okay, and I think that's pretty much it, right? Yeah, that's pretty much it. For all of the things that I've done, it's two files that are based off of two scripts that are based off of ones that already exist, but they've been modded so that I could create my own master node and then be able to customize the code generation for that specific master node so that I could use lighting. And of course, like I said, all of this could break in the future, but at least for now, I have the ability, and you can also have the ability to have some really nice lighting in your game so that people are more likely to look at your game and be like, ooh, that's cool, and follow your development. Because that's really, I think, for any indie dev, that's the main priority is, you know, getting people on board with your game idea and, you know, starting a follower base, essentially. But anyway, yeah, that's pretty much it. It's a folder inside of the assets, and it has this custom script that I showed. There's an editor folder for these two things that I just showed, this smaller script and this giant, well, no, this is the smaller one. This is the giant one that's 500 lines long, but that's just because I copied other classes into here and changed the names of things to kind of get it all working. But yeah, hopefully from this you can kind of get a general idea of how to do this yourself so that you don't necessarily have to download any files or folders or whatever. You can just do the modding yourself, because you can totally do this. You can do it. You can do these moddy things. It's hacky, but you know, you gotta do what you gotta do if you want your nice lighting. And then also don't forget this weird assembly reference thing. So yeah. So thank you for watching. That's all I have, pretty much I have to say. But don't leave quite yet. Don't leave quite yet. Again, just final words. If you go in the description and there's no download link, then hopefully this video will give you enough information to set up to mod the game, to mod your project for yourself. Not game. Well, it is a game, but it's an engine to mod the package itself. And yeah, good stuff. If you have any questions, I can answer them in the comments section. Definitely, you know, if you're having any issues, I'll try to get back to them. But I have my own project that I'm working on, so I might not that, but this right here, I have my own project that I'm working on with another friend. So obviously YouTube isn't my, you know, I don't dedicate a lot of time to it, but this is what I do dedicate my time to. And in case you're wondering, what game is that? What are you making? If you like what you see here, well, I'm going to tell you what you're looking at. Not this. Oh, my windows. Oh my gosh. Here we go. So if you're wondering what the heck this is, looking at this cool lava and thinking, what game is this? I see a mining helmet. What is that all about? Well, it's a game that me and my friend are making called Below the Stone. That's the game. That's the name of the game. It's a game about dwarves, and it's got pixel art graphics, and you're going underground. It's procedural generation, and there's crafting, and there's missions, and it has a role play aspect to it. And it's a roguelite, not a roguelike, but a roguelite. So it has the feel of a roguelite game, but it has the feeling of something more like Terraria, where when you die, you lose your items. Okay, so if you're interested in those types of games, if you're interested in, you know, games that have procedural generation and fully destructible levels and all that cool, awesome goodness that I love about games that I've played in the past, then you should check out our game. And you can check it out at strollart.com. That's strollart with 2 L's. And I'm also going to have probably some links in the description so that you can go to our website, or you can even visit our Discord. Our Discord is quite active. We got, you know, people, if you join, they'll greet you, so don't be afraid when people greet you. It's not them trying to be trolls. They're just being friendly, okay? I know this is the internet, but come on, guys. Let's be civilized here, right? The internet is a thing made by people, and people are civilized, so let's be civilized. Although when I say that, I know that doesn't guarantee that. But yeah, if you like what you see here, I mean, if you're watching this video and this is the first video you've seen of me, if you go on my channel, you'll see some other progress videos and some other videos showing off our game. So if it's like, I just want to see what your game looks like, you know, there are some videos on my channel you can click on and check those out as well. But yeah, wish list us on Steam. If there's one thing you can do to support us, wish list us on Steam, and follow us on Twitter, maybe even. All of our social links will be on our website, so that's why that's here, because that's basically our kind of the one link to rule them all. So yeah. Let's see, is there anything else I want to say? Thank you to our patrons. Actually, yeah, that's one thing that's one thing I want to say, actually, is thank you to our patrons, because we do have a Patreon. And our newest addition to our pantheon of Patreons is a guy by the name of Blank Tester. So I'd like to personally give him a thank you and a welcome to the pantheon. And anyone else who joins, any new people who join our Patreon, we'll definitely give them a nice warm welcome in another video of ours. Of course, we also thank them on Twitter and in other places as well. We have a special chat on our Discord for patrons, and we give monthly test builds to our patrons as well, so that they can test our game and enjoy being able to test the game, but also knowing that they are the first people to ever play our game before anyone else. So yeah, if any of this sounds cool to you, check us out. Okay, let's see if there's anything else. Is there anything else I want to say? I don't think so. I don't want to hold you guys any longer. Thank you guys for watching. Check the description, post comments, like the video. I don't like saying that. I don't care if you subscribe, but like the video, share it with people that are working on 2D projects in Unity, and if they're using the URP or anything like this, or they're making a game and you think it would look cool if it had stuff like this, then share this video. Spread the wealth of knowledge, and have a nice day. That should be my intro. Spread the wealth of knowledge. Okay, see you guys later.